So here you can take a break. You can pause for a little time. We will also take a small break. When we come back shortly, then we will try to do a small mental break for you, and then we will proceed for the rest of the class. Welcome back from the break. If you have taken some water or something. For the mental break, well, a person is walking on the street, and there is a beggar. He is asking for food. Please, can you give me some food? This guy who is walking is in, right, say London or someplace. He says that, you see, I have a beer can in my hand. I don't have food. I can give you a beer, which is a drink. The beggar says, no, I don't drink. Then the person says, okay, you see, I am smoking this very costly cigar. If you like, I don't have food, I'll give you this cigar. The beggar says, I don't smoke. So then that person says, okay, you see, I am just walking to the racetrack. I am going to the horse race. So if you like, you can come with me and you can enjoy the horse race. The beggar says, I do not bet, I do not gamble. So why should I go to horse race? So now this guy is, he gets that, you see, this beggar is very strange. He is not accepting anything. So he makes a joke. Okay, I can arrange a girlfriend for you. Would you like that? Now the beggar becomes very, no, I love my wife. I don't want uh, any girlfriend or anything. If you can give me food, please, otherwise. So then that person says, okay. You see, I'll give you food, and I will even give you some money. But for that, you will have to come with me to my house. He said, okay. He said, you see, I want to show my wife. That is why I want you to, I could have gone to a store and given you some food, but I want you to come with me to my house so that I can show my wife that if a man does not smoke, does not drink, does not gamble, has no girlfriends, and loves his wife, then what happens to that man? He becomes a beggar. Okay, so hopefully the mental break has been there. You enjoyed it. Let us proceed further. We are now talking of non-equilibrium solidification of alloys. You see, when we have any metal which is completely in the molten state, and then we start to cool it until it starts to become solid. If it is a pure metal, the temperature will remain constant until all the liquid metal has turned into a solid, and then the temperature will start to drop again. If it is an alloy, binary alloy like copper and nickel, then both are completely melted and mixed together. We will drop the temperature until the freezing point of one metal starts. So one of the metal starts to freeze and the temperature keeps on dropping. In the meanwhile, the other material also starts to solidify. Ultimately, at a certain point, both of them do, right? But this happens if the cooling rate is relatively slow, right? We allow it to cool at a slow rate. But if we want to cool it very quickly, right? If we put a fan there, or if we decrease the temperature very quickly by a thermostat and so on, then the cooling will be very quick, and there will not be enough time for all the mixed solid to completely solidify. So what will happen? If there is rapid cooling, then cores will be formed. This whole metal will not be this. I am very sorry we went back. So, but let us see. We are still not bad. We are here, right? So if you see that, you see the liquid is there, but when we are cooling quickly, then small pieces start to form of the solid. And if we keep on cooling at a normal rate, the whole thing will solidify. But otherwise, some part will solidify at a different rate, some part will solidify at a different rate. So some cores, C-O-R-E, will be formed. Some cores will be formed. If you see here, you see this is the liquidus. Now this is the solidus line. This is the solidus line if we are going at a very slow and equilibrium rate of cooling. But if we do it quickly, then we get a different line. So therefore we don't go here, we don't go there, we don't go there. We have other points. So when we have these other points, then small pieces of a different solid are there. The rest of the solid is a homogeneous solid, the copper nickel system or something. But some portions here are different than the rest. It is called a cored structure, C-O-R-E-D. It is called a non-equilibrium structure. So if you let it solidify at the natural rate, then it will solidify and form one uniform solid phase alpha or whatever. But if you force cool it, then some small different pieces of solid will form inside, which are called non-equilibrium solidification. Right? Now we are starting a totally different topic. So, right, take a little 5-second break. Until now, what was the topic? The whole topic was binary isomorphous alloy system. Binary isomorphous alloy system. There are two metals or a metal and a non-metal which is making the alloy system. And once it is completely solidified, there is only one solid phase, so it is isomorphous. This time we again have a binary system, so we will have two metals or one metal and a non-metal in the alloy system, but it is not isomorphic. It is a term called eutectic alloy system. Eutectic alloy system, right? So eutectic is a special point, and rather than explaining it here, I think I will go to the next slide, which is a slightly bigger diagram, hopefully of the same thing, and then we will explain